Welcome to Astronomy Daily, the podcast that brings you the universe one story at a time. I'm Avery.
And I'm Anna. It's great to be with you. We've got a packed episode today, from major moves in the space industry to a potential solution for one of the biggest mysteries in cosmology.
Let's start with that industry news. It's a big one. Blue Origin has just hired Tory Bruno, the former president and CEO of United Launch Alliance, or ULA.
That's a major headline. Bruno is a giant in the industry. He's going to be heading up Blue Origin's new national security group.
Exactly, and it makes so much sense when you think about it. Bruno was instrumental in transitioning ULA to its new Vulcan rocket. And what engines does the Vulcan rocket use?
Blue Origin's BE-4 engines. It's all connected. This move signals that Blue Origin is getting very serious about competing for those lucrative national security launch contracts, especially with their new Glenn heavy lift rocket on the horizon.
It's a strategic chess move. Bringing in someone with Bruno's experience and connections is a clear sign of their ambition in that sector.
Speaking of ambitions, let's shift from the business of space to one of its greatest mysteries, dark matter. A new study is proposing a fascinating, if somewhat exotic idea.
I'm always ready for a new dark matter theory. What's this one?
Well, instead of tiny, undiscovered particles, this theory suggests dark matter could be made of giant star-sized objects that don't emit light. They're calling them exotic astrophysical dark objects, or IADs.
IADs. I like it. So what would these objects be?
Things like boson stars or cue balls, very dense theoretical objects. The really cool part is how we might find them. If one of these IADs passes in front of a distant star, its immense gravity would bend the starlight in a very specific way.
Right, gravitational lensing.
Exactly, but a very specific kind. Instead of just brightening, the star's apparent position in the sky would seem to jump suddenly. It's a unique signal, and researchers think they can hunt for these jumps in the massive dataset from the Gaia Space Telescope. It's a long shot, but it's a testable hypothesis.
From hunting for invisible objects to tracking a very visible one, let's talk about Asteroid Apophis.
Yes, everyone's favorite god of chaos asteroid. It's making a very close pass by Earth in 2029.
An incredibly close pass, just 32,000 kilometers away, which is closer than some of our satellites. And to take advantage of this rare opportunity, the European Space Agency and Japan's JAXA are teaming up for a new mission called Ramses.
So what's the goal of Ramses?
The mission will get up close to the 375-meter-wide asteroid to study how Earth's gravity affects it during the flyby. We expect our planet's gravity to cause changes in Apophis's spin, maybe even trigger some landslides or quakes on its surface.
And understanding those gravitational effects is crucial for planetary defense. If we ever need to nudge an asteroid out of the way, we need to know precisely how it will behave. This kind of international cooperation is exactly what we need for ensuring space safety.
That's right. And speaking of understanding the cosmos on a grand scale, let's talk about all the stuff that isn't in asteroids or even galaxies. I'm talking about normal matter, the stuff that makes up you, me, and the stars. It turns out we've been missing most of it.
This is one of my favorite cosmological problems. The Big Bang Theory predicts a certain amount of normal matter in the universe, but when we add up all the stars and galaxies we can see, we only find about 10% of it. So where's the other 90%?
For a long time, the theory has been that it's hiding in the vast spaces between galaxies, in a hot, thin soup of gas called the intergalactic medium. It's often called the cosmic web. But it's so diffuse that it's been nearly impossible to detect directly.
Until now, right? This is where fast radio bursts come in?
Precisely. A new study used these powerful, millisecond-long blasts of radio waves from distant galaxies as probes. As an FRB signal travels across billions of light years, it gets slightly dispersed by the gas it passes through. By measuring how much the signal is smeared out, astronomers can calculate how much matter it encountered.
And the results confirmed the theory?
They did. The numbers match perfectly. The missing matter was in the cosmic web all along. It's a huge victory for cosmology. We finally completed the census of normal matter in the universe.
That is incredible. From the cosmic web, let's zoom back in much closer to home, the chaotic space between the Earth and the Moon.
It's an area that's about to get a lot busier with programs like Artemis and the Lunar Gateway.
Right. And navigating that space is notoriously difficult because of the complex, shifting gravitational poles of the Earth, Moon, and Sun. It's the classic three-body problem. So to help future missions, researchers at Lawrence Livermore Laboratory have done something amazing.
What's that?
They've created and released an open source data set mapping 1 million different stable trajectories in that cis-lunar space. It's being called a gold standard map that companies and space agencies can use to validate their navigation software.
So it's essentially a comprehensive roadmap for the Earth-Moon system. That's invaluable. It helps identify stable regions, like the Lagrange points, where we could place future infrastructure like the Lunar Gateway. It's a foundational piece of work for the next era of lunar exploration.
Absolutely. And before we go today, let's take a brief look at some of the major astronomical events to look out for in 2026, which is just around the corner.
I love these previews. What's the biggest highlight?
Without a doubt, the total solar eclipse on August 12th. The path of totality will cross over Greenland, Iceland, and parts of Spain. It's going to be a major event for skywatchers in Europe.
And for those of us in North America, we get a treat a few months earlier, a total lunar eclipse on March 3rd, 2026.
There's more too. Jupiter's moons will enter a mutual eclipse season, meaning we can watch them pass in front of and behind one another. And both the Perseid and Geminid meteor showers are expected to have excellent viewing conditions, with no bright moon to wash them out.
Plus, solar activity will still be high as we come down from the peak of solar cycle 25, so there's a good chance for more impressive aurora displays. 2026 is shaping up to be a fantastic year for astronomy.
It certainly is. And that's all the time we have for today. We've gone from corporate boardrooms to the edge of the visible universe and back to our own lunar backyard.
Thanks for joining us on Astronomy Daily. If you'd like even more space news, just visit our website at astronomydaily.io. Or look out for us on social media. Just search for Astro Daily Pod on all the major platforms. I'm Avery.
And I'm Anna. Join us next time as we continue to explore the cosmos. Clear skies.